Hello dear students, in the today's class we will solve another type of problem related to statistical analysis of the data. Now look at the problem number 2. Here the following 10 measurements of the resistance of a resistor gave the value as 101.2 ohm, 101.7 ohm, 101.3 ohm, 101.0 ohm, 101.5 ohm, 101.3 ohm, 101.2 ohm, 101.4 ohm, 101.3 ohm and 101.1 ohm. Here assume that only random errors are present. So calculate the first term, that is arithmetic mean, second term is deviation from mean, next term is average deviation, fourth term that is standard deviation, next one is variance, and the last term which you have to find the value is probable error. Since in this problem there are 10 set of readings, so that the method of solution for this problem is little bit different. That means we should draw the table like this. In that we should write the term that is readings as xn, and next term that is deviation. In that we should write two term, that is dn and dn square, like this. As we know that in this problem there are 10 set of readings, so that in the readings column we should write the value of all the set of readings, such as x1 is equal to 101.2 ohm, x2 is equal to 101.7 ohm, x3 is equal to 101.3 ohm, x4 is equal to 101.0 ohm, x5 is equal to 101.5 ohm, x6 is equal to 101.3 ohm, x7 is equal to 101.2 ohm, x8 is equal to 101.4 ohm, x9 is equal to 101.3 ohm, x10 is equal to 101.1 ohm. So that here 10 set of readings in the given problem. Now next step is add the all 10 set of readings, so that summation xn is equal to 1013.0 ohm. Here in this problem we know that total number of readings taken, that is small n, is equal to 10. Now we can find the value of arithmetic mean. Here we know that the equation for arithmetic mean, x bar is equal to summation xn, where n is varying from 1 to n, divided by n. Here we know that total number of readings n is equal to 10 and summation xn is equal to 1013.0 ohm. Now substitute these two values in the above equation, so that arithmetic mean x bar becomes, x bar is equal to 1013.0 ohm divided by 10. After calculation, the value of arithmetic mean x bar is equal to 101.3 ohm. This is how we can solve the value for arithmetic mean. Next term, that is deviation from mean. Here the equation for deviation from mean is dn is equal to xn minus x bar. In the given problem we should get 10 set of deviation from mean, that is dn is equal to d1, d2, d3, d4, d5, d6, d7, d8, d9 and d10. So that here d1 becomes x1 minus x bar. Substitute the value of x1 and x bar, we will get the answer for d1 as minus 0.1 ohm. Similarly, d2 is equal to x2 minus x bar. Now the value of x2 is 101.7 minus x bar is 101.3. After calculation, d2 becomes plus 0.4 ohm. Next, deviation from mean, that is d3, it is equal to x3 minus x bar. Here after substitution of the value in the equation, d3 becomes 0 ohm, because the value of x3 and x bar is same, it is 101.3. After calculation, d3 is equal to 0 ohm. Similarly, d4 is equal to x4 minus x bar. After substitution of the value, d4 becomes minus 0.3 ohm. Similarly, d5 is equal to x5 minus x bar. Now here x5 is 101.5 and the value of arithmetic mean, that is x bar, is 101.3. After calculation, d5 becomes plus 0.2 ohm. Similarly, d6 is equal to x6 minus x bar. Here after substitution of the value, d6 becomes 0 ohm. Similarly, d7 is equal to x7 minus x bar. Here the value of d7 is minus 0.1 ohm. d8 is equal to x8 minus x bar, so that after substitution of the value, d8 becomes plus 0.1 ohm. d9 is equal to x9 minus x bar, so that d9 is equal to 0 ohm. And the last value, that is d10, is equal to x10 minus x bar. After substitution of the value, d10 becomes minus 0.2 ohm. This is how we can find the value of deviation from mean. So the deviation from mean for all the measured values are d1 is equal to minus 0.1 ohm, d2 is equal to plus 0.4 ohm, d3 is equal to 0 ohm, d4 is equal to minus 0.3 ohm, d5 is equal to plus 0.2 ohm, d6 is equal to 0 ohm, d7 is equal to minus 0.1 ohm, d8 is equal to plus 0.1 ohm, d9 is equal to 0 ohm, and the value d10 is equal to minus 2 ohm. After the solution of deviation from mean, it is very essential to write the value of deviation, that is dn becomes d1 is equal to minus 0.1 ohm, d2 is equal to plus 0.4 ohm, d3 is equal to 0 ohm, d4 is equal to minus 0.3 ohm, d5 is equal to plus 0.2 ohm, d6 is equal to 0 ohm, d7 is equal to minus 0.1 ohm, d8 is equal to plus 0.1 ohm, d9 is equal to 0 ohm, and d10 is equal to minus 0.2 ohm. Now the next step is we have to add these 10 deviation value. During calculation, we should remember that we should neglect the negative sign in the given value, so that summation dn becomes 1.4. Next term, that is average deviation. Here the equation for average deviation DAV is equal to summation dn, where n is varying from 1 to n divided by n. This equation can be written as DAV is equal to d1 plus d2 plus d3 plus d4 plus up to dn whole divided by n. We know that total number of readings taken n is equal to 10, so that the equation becomes DAV is equal to D1 plus D2 plus D3 plus D4 plus D5 plus D6 plus D7 plus D8 plus D9 plus D10 whole divided by 10. Here substitute the value of deviation. After substitution, DAV becomes 1.4 divided by 10, and after calculation DAV is equal to 0.14 ohm. This is how we can find the value of every deviation. Now the next term is standard deviation. Here we know that standard deviation is denoted as sigma, so that sigma is equal to square root of summation dn square, where n is varying from 1 to n divided by n. This equation can be rewritten as sigma is equal to square root of d1 square plus d2 square plus d3 square plus d4 square up to dn square whole divided by n. Since the number of readings taken in the given problem n is equal to 10, which is less than 20 readings, so that the equation becomes sigma is equal to square root of summation dn square, n is varying from 1 to n divided by n minus 1. This is very important during the solution of the problem. Now, according to our problem, sigma becomes square root of d1 square plus d2 square plus d3 square plus d4 square plus d5 square plus d6 square plus d7 square plus d8 square plus d9 square plus d10 square whole divided by 10 minus 1. Now next step is substitution of all the values in the given equation. Before that, what we have to do is, here square the individual deviation value. Now look at here, the value of deviation, that is d1, is equal to minus 0.1 ohm. Now what is the squared value of d1? That is 0.01. Similarly, we have to find the squared value of d2, that is 0.16. Similarly, d3 squared value is 0.00. Next, d4 squared value is 0.09. Next one is 0.04. Next value is 0. Next, seventh deviation squared value is 0.01. Similarly, d8 squared value is 0.01. And last, d9 is 0.00. And then d9 is 0.00. Now, last value, that is d10 squared value is 0.04. After summation of dn square, the value becomes 0.36. That means we should add all the squared value of deviation and get the answer as 0.36. After that, substitute the value of all the deviation in the standard deviation equation. It becomes sigma is equal to square root of minus 0.1 square plus 0.4 square plus 0 square plus minus 0.3 square plus 0.2 square plus 0 square plus minus 0.1 square plus 0.1 square plus 0 square plus minus 0.2 square whole divided by 10 minus 1. After calculation, sigma becomes 0.2 ohm. That means the standard deviation sigma is equal to 0.2 ohm. This is how we should solve the term standard deviation for the given problem. Next term, that is variance. Here we know that variance capital V is equal to standard deviation whole square. Standard deviation is denoted as sigma, so that equation becomes V is equal to sigma square. We know that standard deviation sigma is equal to 0.2 ohm. So that substitute the value of sigma and variance V becomes V is equal to 0.2 whole square. So that V is equal to 0.04 ohm. And the last term, that is probable error. Here probable error R is equal to 0.6745 into sigma. You know that sigma is equal to 0.2 ohm. Now substitute the value in the given equation, so that probable error R becomes R is equal to 0.6745 into 0.2. After calculation, the value of R becomes R is equal to 0.1349 ohm. This is how you have to solve the value of variance and probable error. This is what end of the presentation. In the next class, we will try to solve another 2 problems related to statistical analysis of the data. Thank you and see you in the next video.